بسم الله الرحمن الرحيم. نستكمل دروس الإلكتريكال ماشين 8 و 3. هذا استكمال للدرس الماضي، درس السابع وهذا هو الدرس الثامن Types of DC Generator. النوع الثالث من أنواع DC Generator من Self-Excited Family is the Compound DC Generator. Compound DC Generator حيكون له shunt field and series field. So it comes into two main types. في long shunt في short shunt DC compound generator. فراح اخذ في البداية اللونج شانت والايكويفالنت سيركت له عبارة عن شانت فيلد موصل على parallel مع سيريس فيلد، وهنا الارمتشر of the DC generator، والتيرمينال اوتبوت تكون مأخوذة مع اطراف السيريز مع الارمتشر. هنا الارمتشر ريزيستنس، سيريز فيلد ريزيستنس، وشانت ريزيستنس. هنا الباك EMF، وهنا التيرمينال فولتج. بالنسبة للشورت شانت فنفس الشيء، حيكون عندنا الشانت فيلد وايندينج موصل دايركت مع الارمتشر وايندينج، والسيريز فيلد وايندينج حتكون برا الدائرة. Terminal of the DC generator is between the series field والshunt, one terminal of the shunt armature winding. المعادلات التي تحكم الأداء كل من النوعين هذه، أو equations that governs the characteristics of this DC generator, is the following. This is the armature current coming out of the armature winding. So there will be a shunt current to magnetize the field winding of the shunt field, and then the load current if we connect some DC load here. فالتيار حيكون ال I armature is equal to the shunt current plus the load current من Kirchhoff current law. A shunt current is equal to the terminal voltage، الفولتج اللي على أطراف الارمتشر، على أطراف الشنت فيلد اللي هي ال V مقسومة على ال R shunt. عندنا معادلة الفولتج، ال V terminal voltage حتساوي الفولتج المتولدة voltage induced between the armature winding between the brushes minus the voltage drop on the armature resistance minus the voltage drop on the series resistance, series field resistance, which is this one. Then V is equal to E minus, I will take IA, the armature current, as a common, and then it will remain RA plus R series. Let's now calculate the powers. there will be generated power, or what we call it developed power, in the armature, which is the generated voltage multiplied by the armature current. This is in watts. Then there will be a power loss, P copper loss, on the armature. So the P copper loss, there will be a copper loss on the armature resistance, a copper loss in the series resistance, a copper loss on the shunt resistance. The total copper loss in this machine will be IA square multiplied by the armature resistance plus the series resistance plus the copper loss into the armature, into the field windings, which is I shunt square multiplied by R shunt. This is the total copper loss in this machine. The output power, or B load, will be the voltage across the load multiplied by the current that is flowing through the load. Compound DC generator long shunt. What about the short shunt? The short shunt, the armature current here flowing out of the armature winding is no longer equal to the series current that is flowing through the series field winding. Thus, there will be I load flowing through the series winding when there is a load connected across the terminal of the generator. And there will be, of course, a shunt current flowing through the shunt field. So the armature current is also equal to I shunt plus I load. I shunt is also equal to the the shunt current is equal to V, the terminal voltage, plus IL R series over the shunt resistance, because I want to know the voltage here, how much the voltage is here. When I will find this voltage, I can divide it by the shunt resistance to get the shunt current. Thus, I can find it in two ways. The first way is the terminal voltage is known, so terminal voltage plus the voltage drop across the series field resistance. Or I can say it is the generated voltage here, E, minus the voltage drop on the shunt resistance, on the armature resistance, sorry. So it's E minus, this is a minus, IARA. So there are two ways to figure how to find the shunt current. The voltage here, terminal voltage, is equal to the same thing. It is E minus IA RA minus the voltage drop on the series resistance, the series field resistance, which is I series, I load, R series. This is the voltage equation. The rest of for example, the developed power is always the same for all machines, DC machines, DC generators, but the copper loss will depend on the current. So IA square into RA plus I shunt square into R shunt plus IL square into the series resistance. So this is the total copper loss into the machine, because the current flowing into the series field resistance is no longer equal to the current that is flowing through the shunt resistance. Now, since we have seen all the types of DC generators, I will begin solving problems regarding DC generators. So example number 1. Example: a shunt generator delivers 450 amps at 230 volt, and the resistance of the shunt field and the armature are 50 and 0.03 ohms respectively. Calculate the generated EMF. The first step for solving such an example is draw the equivalent circuit for this particular type of DC generator. So it is a shunt generator, thus this is the equivalent circuit for such type. He said that delivers 450 amps means that the I load, the current that the load is consuming, is 450 amps at 230 volt. This means that the voltage across the load is 230 volt. It means that the V voltage terminal on the generator is 230 volt. I load is 450 amps. The resistance of the shunt field and the armature are 50 and 0.03 respectively, means that the armature resistance, the shunt resistance is 50 and the armature resistance is 0.03. So our shunt is equal to 50 ohms, our armature is 0.03 ohms. He wants the generated EMF. E in this case is equal to V, the voltage on the terminal of the generator, plus the voltage drop on the armature winding. So you can find it in this way. On the terminal there is a voltage of 230, plus the voltage drop on the resistance will gives me E, because the current is flowing out of the generator armature winding. So V is 230 plus IA into 0.03. So this is one equation with two unknowns. We have to find the current I. So IA is equal to, in this type of generator, it is I shunt plus the load current. The load current is known to us, it is 450, but the shunt current is unknown. To find the shunt current, it is the terminal voltage divided by the shunt resistance. Terminal voltage is 230, the shunt resistance is 50 amps, and this will be, thus it will be 4.6 plus 450, thus it will be 454.6 amperes. Then it will equal to 230 plus 454.6 multiplied by 0.03. This will gives us 243.6 volt. So this is the answer for this question. If I added a question on this example, also calculate the generated power. If I want to find the generated power, it's very simple. P generated is equal to E multiplied by IA, and this equal to 243.6 multiplied by 454.6. This will gives us some power in watts. Also, if I want to find the generated power, is what we said before, is the developed power. If I want to name it in another name, the copper loss, the total copper loss in this type of machine, it will be IA square into RA plus I shunt square into R shunt. So it will be 454.6 square multiplied by 0.03 ohms plus 4.6 ampere square multiplied by 50 ohms, and also it will gives us some wattage. Let's go to example number 2. Okay, this is example number 2. A long shunt compound generator delivers a load current of 50 amps at 500 volt and has an armature, series and shunt field resistances of 0.05, 0.03 and 250. It means that the armature resistance RA is 0.05, R series is 0.03, and here is our shunt. Calculate the generated voltage and armature current. Allow a 1 volt per brush for contacts drop. Is to draw the long shunt compound generator. This is the field winding series, and then the armature resistance, this is our shunt, our series, our armature, generated voltage, and then here is the load connected across the generator terminals. So I load 50 amps, V is 500 volt, then E, the generated voltage, is equal to the voltage across the load plus armature current multiplied by armature resistance plus the series resistance plus the voltage drop across brushes, V brush, because he mentioned that there is a voltage drop on the brush, which is this one and this one. So first we have to find the armature current in order to find E. Armature current is equal to shunt current plus the load current. The shunt current is equal to the voltage over the R shunt, which is 500 volt divided by the shunt resistance, which is 250, and this is 2 amps. So this one, it will be 2 amps plus the load resistance, which is 50, it is 52 amps. then E, it will equal to 500 volt plus 52 multiplied by 0.05 plus 0.03 plus the voltage drop across the brushes. He said here 1 volt per brush. We have 2 brushes, so 1 volt here and 1 volt here drop. It will be plus 2, so it's 506.16 volt, and this is the answer.